Welcome back, everyone. We just finished doing what's called class full subnetting, meaning you have the same subnet mask or number of hosts in the same segment. But that is not really the reality. It used to be the reality. Now the reality is that you have classless subnetting, which is called VLSM. That is the birth of VLSM. It was a mechanism that was created to slow down the inevitable, if that's how you say it, demise of IPv4. Okay? So what VLSM is, it stands for variable length subnet mask, as the word says. It will vary throughout the network segment based on the needs of the network. Okay? And you see this diagram that I have back here. Now, I believe in my book I have this diagram, but for those of you who have the book, I'll give you a better explanation now, or an explanation if you found it somewhat confusing with the numbers and all that. All right, we have an infrastructure that you see here. This is one company, let's say an enterprise company, that in one portion, one branch headquarters or whatever, one branch office, you have a need for 3,500 IPs. On another one, you have 725, and another one you have 100. And then, of course, you need 2 IPs per segment here to connect from router to router, router to router. So the rule of VLSM, number one, is that you need to always use the zero network. Because the whole point of VLSM is not to waste IP addresses. So you want to be able to use the whole spectrum. So you will always use the zero network when working within VLSM, variable length subnet mask. Okay? And then you would start from the highest number of IPs and work your way down to the lowest number of IPs. Okay? So those are the rules, the guidelines that you want to follow. All right? Now, you have to start with the address that you've been given. As far as the address that we've been given, and I'm going to put these back to what they were. Let me do it here because I don't want to cause all sorts of craziness. Let me do it here real quick. I say real quick, but 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. All right, so we were given a 172.20.0.0 network. Obviously, this is one octet right here, correct? One entire octet right here, all zeros, all 8 zeros. And this is another octet, fourth octet, all 8 zeros. Go ahead and move that back to where it was. There we go. No? I guess we can move a little bit more this way. All right. And what the yellow numbers, as it explains here, all the numbers in yellow are the network increments. Because as we start drawing our lines, I put the numbers in yellow as your network increment. We'll check as I go, make sure there's no mistakes. And the numbers up here in red, these numbers are used to calculate for broadcast. It's the same scenario when we do the diagram, when we explain the diagram, that the numbers to the right are used to calculate for broadcast. The sum of the numbers to the right, that will equal the number that you calculate broadcast. All right, so what do we have here? The first number of nodes, the largest number of nodes is 3,500. We have a starting point of 172.20.0.0. That is our starting point. That is our starting address. We must start from right there. So let's go ahead and bring this down a little bit here. All right. There's another example down here. So the green bar separates one example from the next. So now we have that. We need to count for 3,500 nodes or hosts. So we know when we count for hosts, we count from right to left, right? And you start at the number 2 and double as you go. So we got 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. So there is where we stop, right? Because we need 3,500. So if we need 3,500, we're good to go right there. So we draw our line between the 16 and the 8. So the 16 becomes our network increment. Now at this point, our network increment we're going to use as a cross-reference to check to make sure that our next starting point is correct. So we drew our line, then we went ahead and said, okay, from the number 8, and then, for some reason my finger just, doesn't like it. All right, these right here, 8 and 2 is 10, and 4 is 14, and 1 is 15. That is why you see that red number 15 up there. So we take and then we add appropriately. And this 255 that you see right here is also the addition or the sum of all these bit values. That's what that 255 represents. So we have 15 in the third octet. So we have 0 here in the third octet. So 172.20, 0 plus 15, we have 172.15. Now the fourth octet is 255. So we have 172.20.15, 0 and 255, 255. So that's how we get that. So our line, our very first line that we drew it right here between the 16 and the 8. That means that those bit values to the left just turned on. So now your new mask for that particular network, for the 3,500 nodes, is a CIDR 20. And remember what CIDR, C-I-D-R, stands for. It's classless interdomain routing. Classless interdomain routing. Now the range, and this is where it gets a little, some people get confused because we're working with two different octets. I think of it as think of the analogy of a car, all right? What's after 0.0? 0.1, right? It's just that you have all 0 miles, you're gonna have, then the first number all the way to the right starts incrementing first before the second number. So 0.1. And then this is just the opposite. Here you have 172.20.15, 255. The last available will be 15.254. Not 14.254, but 15.254. So this will need to go all the way down. Let me get it out of the way. This 254 will need to go all the way down to 0 before this can actually go down to 14. So you do have 3,500 addresses available for this particular network, which if you say, hey, Mr. Administrator, here's your 3,500 nodes, or meaning here's your network ID with your mask, now you can re-subnet that IP address, that network ID, with whatever your needs may be. Okay, whatever your needs may be. So that's the first one. Now, another rule that I didn't mention, once you get to the last IP, because this is an IP regardless, even though we can't use it on the network, that is the last IP. So you say to yourself, okay, what's after 15.255? We've reached the maximum value in that octet, 255. That means that it flips over the 15 by 1 to 16, and then it resets itself back to 0. Therefore, that's our next starting point, 16.0. Okay, 16.0. Which now we can use that network increment, that yellow number, to verify if that's indeed correct. And you see you got 0 and 16, 16. So a cross check. That's all it is. It's a cross check. So now we have our second starting point. Now our second starting point, we get the next highest number of IPs, which is 725. All right, perfect. So now that we have our new starting point, we know what we need to do. We need to draw a new line. So we count again. Well, 2, 4, 8, 16, 32, 64, 128, 2, 65, 12, 10, 24, 20, 48. Well, I think I counted 2. I'm sorry, 1024. That's where my line is at. Sorry. 1024. 512 is too little because I need 725. So the next one over, 1024, will be the correct place to be. So my line would separate between 4 and 2. So 4 will be my network increment. And then if I add 2 and 1, that's 3. That's why you see that number 3 there as the number that we're going to use to calculate for broadcast. So let's go ahead and do so. And again, since we're in the third octet, we still have to add all these bit values on top, which will equal 255, because we're still focusing on the third octet. So we have the 172.20.16.0. So 16 in the third octet plus 3 in the third octet, that gives me 19. Then we go to the fourth octet, 0 plus the 255, 255. So we have a 19.255 as a broadcast. But we did move the line over 2 more bits, did we not? So, well, they're already in there, I guess. I forgot to zero them out or what have you, but we already turned those 2 bits on. So now you went from a 20 at the beginning to a 22. Now that you have the decider 22, you want to find the range. What's in between 16.0 and 19.255? Well, what's after 16.0? 16.1. That's your first available IP address. Last available IP address, one before 19.255, which is 19.254. There you go. Now you have your, and if you want to verify, because you say that you want, hey, okay, I reached the last one. What's my next starting point? What's after 19.255? We've reached the maximum in that last octet there, 255, so it resets itself to 0, right? So that means it incremented that 19 by 1, therefore you have 20.0. So you see that the 4 and 16 is 20. Therefore, we're still okay. Cross-check, just to keep us honest, right? So we already got rid of that. So you hand that to the administrator. Hey, here's your network ID. Here's your new mask. Do whatever it is that you need to do to assign IP addresses to your particular part of the enterprise. Now we do one for 100 nodes. Now with 100 nodes, you know you're going to be in the 4th octet. You know that. So let's count. How many we need? 100. So 100, there it is, right there, between the 128th bit and the 64. That will give us 128 minus 2. For those of you that think, you have to subtract 2 from the host side. So you have your 126 host, which is planning for 100. You draw a line right there. Perfect. Now our focus has changed from the 3rd octet to the 4th octet. Now the first 3 octets do not change. It is only the 4th octet that we're focusing on. Everything else stays the same. Let's go ahead and turn on the bit values now. 1, 1, 1. Okay, we turn on 3 more bits. All right, so we have 172.20, 20, 0. 20, 0. So again, we're in the 4th octet. Am I in the right place? Yes, I am. Okay, 172.20, 20, 0. We're in the 4th octet. Therefore, I need to add 127 because 128 is the increment. I add all the other ones, all the other bits, values, and they turn out to be 127. And really, I'm not adding them. You could add them if you want, just to verify. It's always going to be 1 less the increment, the network increment number. So 127 and 0 is 127. All right, and then of course we have our mask, which is, this is all on, right? So we got 1 more, that's 25. So decider 25. And then you say, what's in between? Well, what's after 20.0? 20.1. What's before 127? 126. See, so the last octet is a lot easier to work with because it's only that 1 octet you're working with. So you have your range, you have your 126 addresses, you give the network ID, that mask, you go, Mr. Administrator, do what you need to do. All right, and then we go to the next starting point. But now, our last address here was 20.127. Our focus is the last octet. What's after 127? 128. So that's our new starting point right there, 128. So if you want to cross-reference again, cross-check, 128, the network increment, plus 0, that's 128. Now you have that 128 there. So that is your new starting point. Now we need to address, since we have every site, if you would. We assign their network ID with their mask, giving it to the administrator. Now we need to find IPs for each particular router. All right, because you know you need IPs for each interface on that router. So we need 2 and 2 and 2 and 2. So our starting point is 128. We need 2 IPs. We know we need to move the line all the way over to right there, because that's a typical number that we use in IT for some reason. We're always using a /30, right? Whoops. That one didn't want to turn on. So now we turn that on, and that turns into a CIDR 30. CIDR 30. So that's our new mask. Now you see that it's 222. So we really don't need to move the line anymore. We just need to go to the next starting point, and then the next starting point, the next starting point. And when you're working with CIDR 30, it's really, really very simple. Now I'm going to show you right now. Now, our starting point was 128. We need to find out the broadcast. We need to add these two numbers, which is 3. So 3 and 128, 131. What's in between? 129 and 30. And we know it's already a CIDR 30. What's after 131? 132. You add the 3, 132 and 3, 135. What's in between? 133 and 134. See that? 135, 136. You had the 3, 139. What's in between? 137, 138. And it's kind of cool because it goes in order. 128, 129, 130, 131, 132, 33, 34, 35, 36, 37, 38, 139. So when you're using a CIDR 30, it's extremely simple because it's like counting. The network, you see the network and the broadcast, whatever is in between. But this is what VLSM is. Are you going to be doing this in the examination? By no means. By no means are they going to sit down and tell you, hey, give you a scenario like this, and then tell you to figure out what the networks are. They're going to give you a very, very simplistic 3 computers, 4 computers. Some of them are already going to have assigned IP addresses, and they need to find out what's the next subnet. And again, you say, okay, it's the same thing. If I ended on this one, what's next after that? And then how many hosts do I need? And then you give the right subnet mask. It's the concept of giving you a starting address, knowing what the last address is, following up, doing, hey, 1525, then the next one, the starting one is 16.0, then I move the line accordingly to find the right mask. But now is you need to get used to, VLSM is nothing difficult. We use it more likely every day. Not every department is going to have the need for the same number of subnets. Now let me clarify something. And I've seen this in many schools that I've been at. You're not going to really use VLSM internally. This is really something that's done externally with public IP addresses. The only reason that we use, as instructors, that we use private IP addressing, because it's something that we're used to seeing on a daily basis. So it's easier on the eyes to look at a private IP address than it would be a public IP address. So, but the reason, the birth of VLSM was that it was to save public IP addresses. So we don't, if somebody needed 1,000 IP addresses at one point, they would say, okay, I'm going to give you a CIDR 16. Now you have 65,000 plus addresses. Way too much, way too much. So now we're allowed to move that line back and forth to meet the needs of the network. And with the new routing protocols, such as RIP version 2, EIGRP, OSPF, or the version 6, the IP version 6 of those routing protocols, they all support VLSM. The only ones that didn't support VLSM was RIP version 1 and IGRP. That's why we no longer use that or teach that, because it's not being used, period. So the newer routing protocols will support VLSM, which is great, all right, because it's going to save our networks, and it's going to be a lot a lot better on our routing tables, and we'll have a lot less waste of IP addresses on our network. So there you go. This is what VLSM is. It's a little bit whatever. You just got to keep track of where you're at. Remember, you have a starting point. You count for the number of hosts. You find your broadcast. What's in between? Next starting point. Same thing over and over and over again. Again, something like this is not what you're going to do. This is something you do to practice, to get used to doing it. In the exam, it's going to be a very, very simple, or I'll give you this. It'll be, let's say, 2 routers. And let's say, what mask would you use between 2 routers? CIDR 30. Right? You know, it has 2 IP addresses. That's the type of questions that you probably confront in the test. All right. There's your VLSM. Very simple. I'll see you in the next lecture.